Okay, in this example, we're going to do a complete graph of a precise graph of a quadratic function or a parabola. So when I say complete, what I mean is we're going to find the vertex, we're going to find the x-intercepts, we're going to find the y-intercept and its corresponding symmetrical point, and then graph. So this it's a nice capstone of all the stuff we've learned with quadratic functions. So we find the vertex. The vertex as the x-coordinate we know is minus b over 2a. So we just plug our points in, our values in. Minus b is 6, so we get minus 6 over 2 times a is negative 1. Negative 6 over negative 2 is positive 3. To find the y-coordinate associated with this x-coordinate, that's nothing more than finding y when x is 3 or finding f of 3. So f of 3 is minus 3 squared. Note that 3 it's not negative 3 quantity squared. Yeah, you might want to explain this. Negatives in front, plus 6 times x is 3, minus 7, and we get 18 plus 18 minus 9 minus 7 is 2. So now that means the point xy, this is the point 3, 2 is the vertex. So let's plot that. 1, 2, 3, up 2. There's the vertex. Before I do this, we know that the graph is going to go down because the leading coefficient is negative, so we know that it's going to come down. We just want to know where does it cross the x-axis and where does it cross the y-axis to get a fairly precise graph. So to find the x-intercepts, well, the x-intercepts are when y is 0. So we set this equal to 0, so we have minus x squared plus 6x minus 7 is equal to 0. Now I like to factor when with the leading coefficient being positive. So I'm going to multiply both sides of this equation by negative 1. That just changes the sign. So we get x squared minus 6x plus 7 is equal to 0. This factors to this does not easily factor. So we use the quadratic formula. Like I said, this is kind of nice because we're putting everything together here that we've learned about quadratics. So x is equal to the opposite of negative 6 is 6. Plus and minus the square root of b squared, negative 6 squared is 36, minus 4 times a, which is 1, times b, which is 7, over 2 times a. And this is equal to, let me see, this should show up on the video. We have 6 plus and minus the square root of 36 minus 28 is 8 over 2. Now, again, this is a nice thing. This can be simplified. So let me do it here and then I'll erase it. So this is 6 plus and minus 8 is 4 times 2. The square root of 4 is 2. So we get 6 plus and minus 2 root 2 over 2. Here, depending on how you explain simplifying, I explain it by factoring out a 2. And this gives us 3 plus and minus root 2, because 3 times 2 is 6. 2 times 3 is 6, and 2 times root 2 is 2 root 2 over 2. Now, because these are multiplied, we can cancel. And the square root of 2, 3 plus the square root of 2, we get about 4.4 4.4 roughly. So we get 1, 2, 3, 4. It's about here roughly. And 3 minus 1.4. We get 3 minus, we get 2, we get about 1.6, or roughly about right there. So there's our x-intercepts. And let me erase this. Now, where is it going to cross the y-axis? Well, we need to find the y-intercept. So to find the y-intercept for any function, the y-intercept is when x is 0. So we just let x equal 0. So when x is 0, we find our y value. This is equal to minus 0 squared. 6 times 0 minus 7. This is minus 7. So the y-intercept is 0, negative 7. Let me plot that. 0, negative 7 is right here. Now, to find the corresponding symmetrical point, let's consider the axis of symmetry. Now we know that's by the definition of symmetry equal. We know, since this is supposed to go right through this. This distance is 3, and by the nature of symmetry, its corresponding symmetrical point must be 3 units to the right. 1, 2, 3, come down to the same line here, and we get the other symmetrical point. Now we've got plenty of points to create our graph, and when I connect these, I'll get something kind of like this, and that gives us a pretty nice hand-drawn, fairly precise hand-drawn graph.